First thing we're going to look at is how to describe and explain the role of the brain in sleep. Remember last time when we spoke about the endogenous pacemakers, the things inside the body that give our body its time. They set the timing for the body. Well, the most important part of the brain for sleep is an endogenous pacemaker. It's called the suprachiasmatic nucleus. Suprachiasmatic nucleus. And it's a cluster of tiny nerve cells found in the hypothalamus, which is a part of your brain that's sort of quite an old part of your brain. Not that your brain has different ages, but that was one of the earlier parts of the brain to be developed. Um, the neurons in the suprachiasmatic nucleus, which we call the SCN for short, they sync up and they fire at the same time, always syncing up, firing at the same time, and kind of setting the time for our body's biological clocks. Remember, we've got lots of different biological clocks in our bodies, lots of things that are based on that suprachiasmatic nucleus that decide how warm we should be, how cold we should be, when different enzymes are released, that kind of thing. And this information is sent from the suprachiasmatic nucleus, the SCN, around the body to reset the internal clocks in every cell. Remember, every single cell has one of these little internal clocks. So these cells keep time in the bodies, but not for very long. So they need to be constantly updated by the suprachiasmatic nucleus. Now, the way that the SCN decides what time it is based on light levels from the optic nerve. So light coming in from the outside hits our optic nerve, and that information is sent to the suprachiasmatic nucleus. And that can sense differences in light, even when your eyes are closed. If you close your eyes right now, you'll notice that you can tell whether there's a light on or not, right? It's not black when you close your eyes. You can tell the light levels there are. Um, if our body clock is kind of running slow, so for example, if the sun rises earlier than it did the day before, the SCM will detect that increased light levels and will adjust the clock, and it puts our body in step with the outside world. We talked a lot about this when we talked about circadian rhythms, and if you remember, we can actually manipulate our circadian rhythm using different light levels, and that's based on our SCNs. So if our SCNs detect more light, we think it's daytime, it makes us more awake. Um, Another part of the brain which is connected to sleep is what we call the pineal gland, Pineal. Um, and that gland kind of secretes a substance called melatonin. And again, we've spoken about melatonin before. It's one of the hormones, one of the substances in the body that makes us kind of sleepier. And the way it does this is it inhibits neurons that produce cortisol, another substance that we find in the body. Cortisol is a neurotransmitter that makes us more awake, more alert, or wakeful. So, because the pineal gland secretes melatonin, which inhibits cortisol production, that means that we get more sleepy. And that pineal gland operates based on signals from, yes, you guessed it, the SCN. So during daylight, the pineal gland will produce less melatonin. In the evening, it'll produce more melatonin. So the SCN is really important in making us sleepier or more wakeful. Melatonin is a drug that you can take that will make you more sleepy because it basically inhibits these cortisol producing neurons. The final part of the brain that I want to think about in terms of how it's related to sleep is what we call the amygdala. Now, when I said that the hypothalamus was one of the older parts of the brain, the amygdala is one of the oldest parts of the brain. You might remember the amygdala from when we looked at it in National 5 Modern Studies, and it's to do with impulse control. Um, and we think it's connected to dreaming in some ways. We don't, to be honest with you, have a lot of detail about the amygdala. We don't really understand it in a lot of ways because it's so old and also quite difficult to get to. But we think that the amygdala has some kind of impact on our dreams. If we have more impulse control, perhaps we are less likely to experience really extreme dreams about doing terrible or wonderful things. But we're not entirely sure.